This is half past paper week 6. We've got all the even numbers. The last one of this series, so all 6 so far have belonged to the same year, 2018 June, if you're interested. And this is a calculator paper. We'll go back to non-calculator next week. All the even numbers, and as usual, we have all the Sparks codes here. If you are a Sparks school, you can use those Sparks codes to look up these topics and get some more practice on them if you do want to do that. Okay, question number 2. Expand and simplify 5p add 3 minus 2 lots of 1 minus 2p. So when we expand brackets, we need to do what's on the outside multiplied by each of the things inside it. So we're doing 5 lots of this first bracket, take away 2 lots of the second bracket. So we're going to do minus 2 lots of this and minus 2 lots of this. So altogether, 5 times p is 5p. 5 times 3 is 15. And then I'm doing minus 2 lots of 1, which is just minus 2. And here's where most students go wrong. You are doing minus 2 lots of minus 2p. And if I'm doing a negative times a negative, that is going to be plus 4p. So our answer here is 9p. I've got positive 5p, add 4 more p. And then I've got 15. I'm taking away 2. And that is positive 13. So that's my final answer. It doesn't matter if you wrote it the other way around, 13 add 9p. But I'm just going to put 9p add 13. You cannot pop that together and make it 22 because they're not like terms. The 9 is with a p and 13 is the constant term on its own. Fantastic. Question number 4. When a biased 6-sided dice is thrown once, the probability that it will land on a 4 is 0.65. The biased dice is thrown twice. Amir draws this probability tree diagram. The diagram is not correct. Write down 2 things wrong with it. So firstly, with tree diagrams, our branches here need to add to make 1. And that's because we're certain to either land on a 4 or not land on a 4. And if that's certain, the probability must add up to 1. So first thing I'm going to say is that 0.65 add 0.25 does not equal 1 on first branches. Great, and to make it really clear, we could even do this. Okay, so the second thing that's wrong, if you actually look at the second branches, it was the probability of it landing on a 4 is 0.65, and actually they've got that the wrong way round here. So landing on a 4, this one should be 0.65, same as it is down here. So the top branch is here. And again, I remember marking this question and lots of people were very vague about which set of branches they're talking about. And that's why I'm kind of making this super clear here. So I'm going to say that the probabilities are on the wrong branches or the wrong way round for the second throw. I'm just going to be really clear and say land on 4 should be 0.65. If you just said they're the wrong way round on the second throw, it's not clear that you're talking about these ones at the bottom or these ones at the top. So just be really clear with that. Question number 6. There are some counters in a bag. The counters are red, white, blue or yellow. Bob is going to take at random a counter from the bag. The table shows each of the probabilities that the counter will be blue or will be yellow. There are 18 blue counters in the bag, so we know that this represents 18 counters. The probability that the counter Bob takes will be red is twice the probability that it will be white. So I know that this probability needs to be double this one. So I'm actually going to write 2x and x. I don't know what the probability is, but I know that red needs to be double white. So if white has a probability of x, then red has a probability of 2x. Work out the number of red counters in the bag. So far, here, if we add together the probabilities that we've got so far, 0.45 add 0.25, that is 0.7. And so we're left with 0.3. We know that probability has to add up to make 1. So 1 take away 0.7 is 0.3. Now you might prefer to think of this as a ratio. The ratio is 2 to 1. But either way, either 2x add x, so 3x equals 0.3, or you can think of it in the ratio 2 to 1, in which case we're dividing by 3. We're taking this 0.3, dividing it by 3, so 0.1, 0.1, 0.1, and x equals 0.1. So therefore, white is 0.1 and red is 0.2. Great. we need to work out the number of red counters in the bag. Now, at the minute, I know that 0.45, which is 45%, equals 18 counters. So I know that that is worth 18. So if I got 5%, for example, that would be dividing by 9. And I'm getting 5% because it's going to be a really helpful amount. I can make it make 10%, I can make it make 20%, I can find out these missing values here. So dividing by 9 is 2 counters. So every 5% is worth 2 counters, which means 10% or 0.1 is worth 4 counters because that would be double. Now we want to know how many red counters there are. Red counters is 0.2, which is 20%. So if 10% is 4 counters, 20% is going to be double that, and that's going to be 8 counters. So 8 is the answer they're looking for there. 4 marks for that one. A marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. There must be an even number of marbles in the box. Explain why. Well, if there was an odd number of marbles, let's say we've got 7 of them, 5, 6, 7. For there to be 50% silver, you would have to have half a marble being silver. So quite literally for this one, you get the mark if you say you cannot have half a marble. It has to be an even number of marbles because you can't have half a marble. If it's going to be exactly 50%, half has to be silver, and so we can't have half a marble, so it can't be odd. Question number 8. ABCDE is a pentagon. So we should know angles in a triangle add up to 180 degrees. Angles in a quadrilateral, a 4-sided shape, add up to 360. And every time you add a side, you add another 180 degrees. So a pentagon, it's really helpful to know a pentagon's 540. The formula for that is the number of sides take away 2 times by 180. So if it's a 5-sided shape, for example, we would do 5 take away 2, which is 3. 3 lots of 180 is 540, but these are just good ones to know anyway. So I know that the angles inside this shape are going to need to add up to 540. It says angle BCD. Now BCD is that angle there. So it's the angle that's made when you go from B to C to D is double angle ABC, and ABC is that angle there. So this one I'm going to call it X, this one I'm going to call it 2X. If this angle is double this one. Work out the size of angle BCD, so that's the bigger one. You must show all your working. So we know that 90 add 115, add 125, add X, add 2X needs to make 540 degrees. So adding together all those angles, 125 add 115, just going to grab my calculator. 125, add 115, add 90. These angles so far, these three, they add to make 330. So I'm going to say 330, add the 3 x's equals 540. Now we want to take 330 away from both sides so that we can solve this. And that is 210. So 3x equals 210. And that's 3 lots of x. I don't want 3 lots of x. I just want to know what x is. So I'm going to divide both sides by 3. I said x and wrote x at the same time. X equals 70 degrees. Perfect. There we go. So once you know that x is 70, I can now go back and say, well, this angle over here, that is 70 degrees. And if this angle here is double, it must be 140. And if you added up all of those angles, they would make 540. In this question, they were asking me for this angle, the angle BCD. So on the answer line, I'm going to pop 140 degrees. We didn't have to give any reasons. They're happy with that. Okay, question number 10. Here are 3 lamps, lamp A, lamp B, and lamp C. Lamp A flashes every 20 seconds. Lamp B flashes every 45 seconds, and lamp C flashes every 120 seconds. The 3 lamps start flashing at the same time. How many times in 1 hour will the 3 lamps flash at the same time? So it'd be helpful for us to know here how long it takes for them to flash at the same time again. And that is looking for the lowest common multiple. So I'm looking for the first number that's in the 20 times table, the 45 times table, and the 120 times table. Okay, so the lowest common multiple of those three values. Now you absolutely can just write out your times table. So you could say 20, 40, 60, 80, 100 and so on, and then 45, 90, 135 and so on. You could do 120, 240, 360. But it's going to take you quite a while, and whenever I see students doing that, quite often they'll just be 10 out or they'll go wrong somewhere. So it's good to have a method as well. But that would absolutely work. If you kept going, you should get to the same number on each. I'm going to do it using the prime factorisation. So 20, if you press on your calculator shift fact, or you can just do the tree thing. So 20 is 10 times 2 and 10 is 5 times 2. So the prime factorisation is 2 times 2 times 5. For 45, we have 3 times 3 times 5. And for 120, we're going to have, let's do 12 times 10, 2 times 6, 2 times 5, 2 times 3. So we're just trying to get to prime numbers on all of them. And that is 2 times 2 times 2 times 3 times 5. I'm now just going to do a Venn diagram. And if they've all got something in common, we can put that in the middle. So let's do A, B, and let's do C down here, like this. So there is nothing that all, oh yeah, there is 5. They all have a 5, so you can put that in the very, very middle, okay? 20 and 120, they share 2 2s. So we're going to put that between A and C. So there's a 2 and a 2, like that. I should say that's A, that's B, and that's C. And then we've got another 2 on 120 that isn't on anything else, so that needs to go just out here. And then I've got a 3 that is between B and C. So I'm going to put the 3 there between B and C. And then they've also got, oh, sorry, they had that one in common. And then there was a spare one on the outside, B, there. Okay, cool. So that's me filling it all in. That's where they go. And if I want to know the first number in all their times tables, I can just times all of those together. So 2 times 2 times 5 times 3 times 3 times 2. Multiplying all of that together is 360. So you just would have had to have kept going with your times tables until you got to 360. So that tells us that every 360 seconds, they flash together at the same time. So 360 seconds. Remember that there's 60 seconds in a minute. So 360 seconds is 6 minutes. So they're going to flash together every 6 minutes. It asks us how many times in 1 hour will the 3 lamps flash at the same time. So 60 minutes divided by 6 is 10 times. That's your answer. So nothing wrong with writing out your 20 times table, 45 times table, and 120 times table, as long as 360 was what you got to as the first number that's in all 3 times tables. You might find that easier. That ended up being pretty complicated, actually. Question number 12. The graph shows the volume of liquid in a container at time t seconds. Find the gradient of the graph. So gradient is for every 1 across, how much does it go up by? So let's say we were here. For every 1 across, how much has it gone up by? Or let's say we're here. For every 1 across, how much has it gone up by? Now, it's quite hard to tell because it's kind of between the squares. So I'm going to use a slightly different method here. I'm going to make a big triangle. So I'm actually going to use the whole line because why not? And gradient is rise over run, or change in y divided by change in x. So the rise, we're going from 4 up to 16. The rise, it's actually gone up by 12 there because we started at 4 and we're going up to 16. The run, we are going from 0 across to 8. So 12 divided by 8 is 1.5. So we'll say the gradient here, for every 1 across, it goes up by 1.5. So 1.5 is our gradient. Explain what this represents. Well, every 1 across is 1 second. And up the side, we're filling up a container, and this is the volume increasing. So I'm going to say every second, the volume increases by 1.5 litres. Every time we go across by 1, every second that's added, we're going 1.5 higher, which means we're putting 1.5 extra litres in the tank or in the container. The graph intersects the volume axis at L equals 4. Explain what this intercept represents. So what does it mean that we are starting here at 4? So when the time is 0, at the beginning of our experiment or whatever we're doing, the volume is already at 4. What does that mean? So that means that when we started, the container already had 4 litres in it to begin with. So the container had 4 litres of water to begin with. There we go. Question number 14. There are 16 hockey teams in a league. Each team played 2 matches against each of the other teams. Work out the total number of matches played. So each of the 16 teams needs to play all of the other teams. So if 16 teams are playing everybody else, there are 15 other teams. They're not playing themselves. That's ridiculous. So 16 times 15 is going to give you that value. But that includes A team playing the B team, and it would include the B team playing the A team. And we don't want to count the same match twice. So we are going to take that value and divide it by 2. And that's going to tell me how many games need to be played for everybody to play everybody. So 16 times 15 divided by 2 is 120. So that would be our answer if we were just playing one match. If every team had to play every other team, that would be our answer. But they're playing 2 matches against each of the teams. So we are actually going to take that answer and times it by 2 because we want everyone to play 2 matches. So the number of matches being played would be 240. Question number 16. The nth term of a sequence is given by an squared add bn, where a and b are integers, so whole numbers. The second term of the sequence is -2, and the fourth term of the sequence is 12. Find the 6th term of the sequence. So if we know what a term of the sequence is, I can put the position number where the n is, and I know it will equal that. So for example, if I had 3n add 5 and I wanted the 10th term, I would change n to be 10. So I would do 3 times 10, which is 30, add 5, and then I'd know that it's 35. So they've given us a lot of information here about our nth term and about our sequence. So the second term is -2. So I know that if it's an squared add bn, when we want the second term in the sequence, we make n 2. So if I do a times 2 squared add b times 2, I know that the answer is going to be -2. Similarly, if I want the fourth term in the sequence, I make n 4. So I know that a times 4 squared add b times 4 needs to equal 12. And I'm just going to sort those things out. So let's just simplify them down. I've got 4a, because 2 squared is 4, add 2b, and that equals -2. And I've got 16a, add 4b, equals 12. And what we now have is simultaneous equations. So what I'm going to do to solve these simultaneous equations, you can either make the a's the same or the b's the same. I think it's going to be easier for me to make the numbers in front of the b's the same, because all I then have to do is times this top equation by 2. So I'm going to write 8a add 4b. So I'm just timesing this equation by 2. As long as you times both sides, that's absolutely fine. It's equivalent. So we've times everything by 2. Sorry, don't forget to times that by 2 as well. And then underneath, 16a add 4b equals 12. Now, then we want to cancel those out. We've made them the same, so we can cancel them out. And here I'm actually going to do the bottom number, take away the top number. So 16a take away 8a is 8a. And because I've done bottom take away top, I'm doing bottom take away top here, but that's fine, that's gone. That's what we wanted to happen. 12 take away -4, minus makes a plus, so that is 16. So if 8a equals 16, then dividing by 8, a must equal 2. And once you know what a is, you can put that back into any of the formula. I'm probably just going to use this one. this one just here. So now that I know that A is 2, I'm going to say 4 times 2, which is 8, add 2b equals minus 2. Take 8 away from both sides, and 2b equals minus 10, so b is minus 5. So therefore, we know that this sequence is 2n squared minus 5n. That is our nth term. We've got the nth term now. We worked out that a is 2 and we worked out that b is minus 5. So now if we want the 6th term in the sequence, we can now just substitute 6 into that nth term. So I'm doing 2 lots of 6 squared minus 5 lots of 6. So 6 squared is 36, doubled is 72. Always do this power before you multiply. Take away 30, 72, take away 30 is 42. And that's your answer for 4 marks. Very tricky, that one. Here are the first 5 terms of a different quadratic sequence. Find an expression for the nth term. So we always do the difference, plus 2, plus 4, plus 6, plus 8. And if that first difference is not the same, we know it's quadratic. We're also told here as well. So we're going to go again, the difference between the difference, plus 2, plus 2, plus 2. And that should be constant. Whatever that number is, you're going to half it. That's just the rule. We're going to divide that by 2. And so that is 1. So I know that my sequence starts 1n squared because that second difference was 2. We always half that number, so it's 1n squared. What is the sequence 1n squared? Well, the first number in the sequence n squared is just 1 squared, so that's 1. The second term would be 2 squared, which is 4. The third term would be 9. The fourth term would be 16, and the fifth term would be 25. We're just doing the position number squared. That's what that means. And then we need to have a look and say, well, I've got 1, but I actually wanted 0. What do I need to do? I need to take away 1. I've got 4, but I actually wanted 2, so I need to take away 2. I've got 9, but I actually wanted 6, so take away 3. I've got 16, but I actually wanted 12, so that's minus 4. And I've got 25, but I actually wanted 20, so we're going to take away 5. What is the nth term of this bit? Well, this is just the minus 1 times table, so minus 1n. So now I'm going to put these two things together, and that gives me my sequence. I don't really want to write 1n squared minus 1n though. So n squared minus n would be a much better answer for our nth term. Well done if you got that. Question number 18, and we've got iteration. Show that the equation x cubed add x equals 7 has a solution between 1 and 2. If there is an answer to it being 7 between 1 and 2, I would expect that when I make x 1, it's going to be too small. And when I make x 2, it's going to be too big, or maybe the other way around. But let's have a look and see. So if I do 1 cubed add 1, I've got 2 as my answer. If I do 2 cubed add 2, 2 cubed is 8, add 2 is 10. Therefore, we expect it to make 7 somewhere in between. 1 was too small, the value of x being 1 was too small, and the value of x being 2 was too big. So I therefore know that there's going to be an answer somewhere in between. This is a cubic, so it's going to look like this. And if it's going to equal 7, if one of the values is too small, the other value is too big, it's going to be somewhere in between. So now for part B, we have to show that the equation x cubed add x equals 7 can be rearranged to give this. Now I'm looking at this and I'm thinking, right, the last thing they've done is cube root. So I'm going to try and get that x cubed term on its own. So by doing my dotted line, what we do to one side, we do to the other. I'm going to start by taking x away from both sides. X cubed is 7 minus x. And then to get the x on its own, I'm cube rooting this side, so I'm also going to cube root this side, and that is the cube root of 7 minus x. We've just moved stuff around, and now it is exactly as they've given me, so we've done that. Part C says starting with x naught equals 2, use the iteration formula xn plus 1 equals the cube root of 7 minus xn 3 times to find an estimate for the solution of that. Looks so complicated, but I promise you it's not that bad. So what you need to get over here is the notation. Xn plus 1 just means the next x. and xn means the x that you're dealing with right now. So think of this a little bit like a sequence. x0 is just our starting value, okay? So we're going to start with x0 being 2. If I want the next x, which is what this means, x1, the next one, x0 is our first one, x1 is the next one, then I'm going to do the cube root of 7 take away the x that we've got at the minute, and that's x0. So if I do 7 take away 2, that's going to get me the next value. So I'm going to do the cube root, so that's shift square root on my calculator, 7 take away 2, so 5, and that gives me 1.709975947. I don't want to round it. I'm just going to keep it in my calculator, and then I'm going to use it again. So now if I want to get x2, the next value of x, I'm going to do the same thing again. The cube root of 7 take away, but now I need to use this answer. So I'm always using the x that I've just had. So it's going to be the cube root of 7, take away my answer that I just got, and that gives me 1.7424188802. And then it says we have to do this 3 times, so x number 3 is the cube root of 7 take away that answer. So again, in my calculator, you can just hit equals if you've used answer and it will re-update it for you. So that is 1.738849506. Don't round anything. Obviously, if you rounded it, you'd say they're all 1.7. So we kind of don't want to round it. We want to write as many decimal places as we can. 1.738849506. I think the mark schemes like you to write at least 5, but I would say just to be on the safe side, just write them all. Fabulous. Question number 20. 50 people were asked if they speak French or German or Spanish. Of these people, 31 speak French. 2 speak French, German and Spanish. Right, I'm already feeling... So last week we had one where it was a 2-way table and we had people going to Britain, to Spain or to Italy, if I remember correctly. And they were either going to one country or another. This question, there is an overlap. People aren't just speaking one language. They might speak 2, they might speak 3. So this is going to be a Venn diagram question. So I need a circle for French, a circle for German, and a circle for Spanish, like that. So 50 people altogether, and 31 speak French. Now I'm going to put that on the outside here just for the minute in a bracket. It's not going on the outside, but I don't know where to put that. That means that this section, this section, this section, and this section needs to add up to make 31, because those are all of the sections that include French-speaking people. So I can't put that 31 anywhere yet. 2 people speak French, German, and Spanish. Now that is okay, I can do that. That's right in the middle. 4 people speak French and Spanish, but not German. So that's okay, they go there. Those 4 people, they speak French and Spanish, so they're between those 2 circles, but they don't speak German, so they're not included in that 2 in the middle. 7 speak German and Spanish. Now, German and Spanish includes those 2 in the middle. It doesn't say not including the French people. So 7 speak German and Spanish. Now, if it's 2 in the very, very middle, and I need that section to make 7, then this bit is 5. Because 2 and 7 now, that bit adds up to 7. 8 do not speak any languages. So let's just do a rectangle here. We've put 8 people out on the outside. They don't speak anything. And 10 people who speak German speak at least one other language. So in this German circle, we know that the people that speak at least one other language, which is those sections there, needs to add up to make 10. I've got 2 and 5, which is 7. So I just need 3 more in this bit here. I now have all of the French sections filled in except for the outside, so I can go back to my 31. 3 add 4 add 2, that's 9. So I'm going to do 31, take away 9, and that is 22. So I therefore now know that that has to be 22 on the outside because it had to make 31 altogether. There we go. So 31 people speak French, we've done. 2 there, 4 there, 7, yep, that's great. 8 do not speak any of the languages, and all 10 people who speak German speak at least one other language. So we also know that there's no one in that section there. We could put 0 if you like. Yeah, let's put 0. There we go. Don't have to. You could have left it blank. So now there's only one section that's not filled out, and that's for people that just speak Spanish. And we know that this needs to add up to 50. So if we add up what we've got so far, we know that the French circle makes 31, that's fine. Add 5, add 8 is 44. So we've taken care of 44 people so far. So there must be 6 people left, and they must be here. Every other section has been filled in. There we go. 2 of the 50 people are chosen at random. What's the probability they both speak Spanish? So the probability of someone speaking Spanish is all of these people out of 50. So the probability of speaking Spanish is 4, add 2, add 5, add 6, which is 17 out of 50. Now, 2 of the people are chosen at random means we're going to take one person. We're not going to take the same person again. So if I've picked someone, I'm now going to pick again, and I want to pick a Spanish person and another Spanish-speaking person. So the probability of Spanish and then Spanish again is going to be 17 out of 50, but I've already taken that Spanish person out. So imagine now there's one less Spanish-speaking person. So now we're going to multiply that by 16 over 49. There are 49 people left, and 16 of them are Spanish-speaking to pick from. So the probability of taking the first Spanish person is 17 over 50, and we're timesing that by 16 over 49 to get the probability of picking 2 people that speak Spanish. And that is 0.111024, blah, blah, blah. So therefore, I'm going to, I could have left it as a fraction, couldn't I? So 136 over 1225, that's one answer. And then as a decimal, 0.111024, and so on. This one's exact, so I think I'm going to leave it as a fraction. 136 over 1225 is your answer. Very well done. Very tricky one there. And that's the end of the paper. I hope you found that helpful. It was 40 marks this week, so yeah. Give you a good indication, half a paper. Let me know in the comments if you've got any questions, and I will see you guys next week for the non-calculator.